All right, welcome back. So last time we worked out the antiderivative of secant, and we saw that it was the natural log of secant plus tangent. And I promised in part 2 we would see a connection with 1 over x squared minus 1. So let's see that. So let's say we wanted to calculate the integral of 1 over x squared minus 1 dx. And we wanted to try it using a trig substitution. So let's say we wanted to use a trig substitution, say x equals sine of theta. Right, we've seen that this will likely simplify if we do it that way. And let's record dx is going to be cosine theta d theta. And we kind of fill this in. Let's see, so we get 1 over the square root of sine squared minus 1 times cosine theta d theta. And then I'm going to work this out. So put equals. I'm going to get down here. This is going to be negative cosine squared. This is going to be cosine of theta. And finally, I'm going to pull that negative sign out, and I'm going to get 1 over cosine of theta d theta, which is negative secant of theta d theta. Okay. Now, luckily, I just worked out what the antiderivative of secant was. It fits just at the top of this screen. So let me fill that in over here. That's going to be, I have a negative sign. So negative the natural log of secant of x. So in this case, that's going to be theta plus tangent of theta plus c. Okay. And so what I need to do now is I need to get this back in terms of x. And one way I can do that is by, for instance, rewriting this in terms of other trig functions, right? So I see secant is 1 over cosine. Tangent is going to be sine over cosine. And I can go back and I can look up here. So I'm now looking up here in my equations, and I see, well, x is equal to sine of theta. So this part here, well, that's going to be x. And I look at it and I say, all I have to do is find cosine, and then I'd be able to plug it in. And so if I know that x is sine of theta, how can I find cosine of theta? And there are a couple ways to do that, but my favorite way is to draw a picture. So my favorite way to do it is say, well, if x is sine of theta, then what do I know? Well, I know that there's a triangle, and this is my angle theta, and I know that the opposite over the hypotenuse, that ratio has to be x, right? The equation x equals sine of theta means I should think of this picture. And then the Pythagorean theorem tells me that the remaining side is going to be the square root of 1 minus x squared. And so, for instance, what this tells me is that the cosine of theta is going to be 1 minus x squared, and I can use that in my calculations. Now, if you don't like this triangle picture, another thing you can do is you can just say that the cosine of theta is the square root of 1 minus sine squared. You can use trig identities if you like. You can use that trig identity, and then you get the same thing, because of course x is sine of theta. So that's another way to think through this. But in any case, we're ready to switch back to green, plug everything in, and we get, let's see, 1 over cosine. So that's going to be 1 over square root of 1 minus x squared plus x over the square root of 1 minus x squared. And now when I get a common denominator, we get x plus 1 all over the square root of 1 minus x squared plus c. Okay. So this is our answer. And so I just want to draw let's do a blue box around both of our answer and our original equation. So the integral of 1 over x squared minus 1, apparently we've just worked it out and gotten this negative log expression here. And what we're going to do in part 3 of the video is we're going to use partial fractions to calculate this integral. And the answer is going to look a little bit different. And then we're going to use some properties of the natural log function to see that they're the same. So stay tuned for part 3.